In this example, you're using a dodgy website, so there's only one IP address, right? But if I was going to Amazon.com or some big website, Netflix.com, would they not send back multiple IP addresses? Because I'm assuming they're doing all kinds of load balancing and stuff like that.
Yeah, you'll see a lot of different, not just one. In fact, like you mentioned, load balancing, and that's one way that they do it. They give some group of users this IP to go to, and the next group of users this IP to go to. And that's a way that they can balance users across a front end. All right, so this is a standard query, nothing special. Message is not truncated. Park that for now. But basically, is this message all there is in this request or in this response? Or is there more? Do I bust the rules of DNS, or am I able to keep this response compact and in just one message?
Hey everyone, David Bommel back with the amazing Chris Greer. Chris, great to have you back on the show.
It is wonderful to be back. David, how have you been doing?
Been a while, dudes. I've been thinking I need to get you back on the show because a lot of people have been asking, we need more Wireshark. We need an updated version of our videos talking about Wireshark, and you're the man I talk to whenever I want to learn about Wireshark. But Chris, last year ended with a whole bunch of outages, and you got to show your shirt because I think it's kind of related to that.
You're spot on, right? Exactly. I was tracking that myself, and have created some content on my channel as well. I mean, you like that? So it's like you got the packet head, you got the good old thing, but it was DNS. So I know it's not always DNS, but in those cases it was.
Yeah, I mean, I think I'd like you to start a series, and I know you've already been doing this on your channel, but I'd like to get you to talk about DNS because I think it's something, some people understand the basics, some people obviously understand more, but in these set of videos that we're going to do, or series of videos that we're going to do, hopefully we'll start with the basics of DNS, but with a Wireshark flavor. So rather than just talking about the theory, you'll show us some PCAPs, and then we'll go a bit deeper. And then if people really want to get into it, they can go and look at the videos on your channel. So I'll link that below. Is that okay? Can we do that?
That would be great. Yeah, for sure. In DNS, I mean, we're seeing it in these breaches. We're seeing it in outages. But there's also some very fascinating statistics for how often it's used in malware. So you mentioned the series on my channel. So yes, it's for the absolute DNS beginner, but also getting into some advanced concepts, not just what can cause it to go down, but also the future of securing it. So we'll be covering all of that in the series, and I'd be happy to bring some of that to you as well.
So just for everyone who's watching, I want to thank Infoblox for sponsoring this video and, helping us create this series. Really want to thank them for their support. And Chris, you had a really cool quote from them relating to malware, right? Perhaps you can show us that.
Yeah, David, you're spot on right. In fact, I was just reading this on the Infoblox site myself. So check out this statistic that 92% of malware leverages DNS for command and control, and that 60% of breaches originate from cloud infrastructure, apps, remote endpoints. But it's staggering how often DNS can be connected to outages within malware. You see it right here, command and control. So the nice thing about that is that it is something we can leverage for malware detection, but also from a troubleshooting standpoint, when we understand how it works, we can quickly find that culprit and get things back up and going.
So there's we were talking offline, there are two big parts to this, right? You're going to talk about DNS with outages being the one issue. And the second part is DNS and security, right?
Yeah, absolutely. Those are the two parts, right? So DNS isn't working for some reason, or there's been a breach, there's been malware infection. How can we leverage DNS to detect that quickly and then, or even protect ourselves from it spreading?
So Chris, let's start with the beginning, right? Let's talk about the basics. I've got my computer, I'm going to a website, whichever website it is, wireshark.org as an example, or your website or my website. How does that process work? So perhaps you can jump into the packets right now, show us that. And then hopefully at some point you're going to talk about DNS security, not in this video, but somewhere along the line, hopefully.
Absolutely, David. So I like to make sure that we understand what we're talking about. So let's back up.
All you gotta do, we just back it up, okay? That's it. Back it up. That's right. Back it up.
Let's just start at how DNS works. You and I know this. We can't go anywhere without DNS. DNS is known as the phone book of the internet. If DNS is down, broken, slow, breach, compromised, everything's going to have a problem, right? So DNS is the mechanics of how we turn a name into an address. Why is an address important? Because an address is where I'm going to send that TCP connection. An address is where my machine has to actually go to retrieve that service, whatever it is. I go to davidbobbal.com. I got to know where that address is. So how do I do that? I do that with DNS. Now, what I'll do is I'll just stir up a bit of DNS traffic here, and we'll capture it with Wireshark, and then we'll dig in and take a look at how it works. What do you think?
Yeah, because I think that, it's one thing to see it on slides. It's one thing to hear about it in theory, but it means so much more when you actually see what it's doing on the wire, like really doing.
Yeah, exactly. And that's why I'm so passionate about packets. That's why I like seeing things at the wire, because then you really get what's going on. So let's do this. I'm just going to fire up Wireshark. I'm just going to, you see my lab traffic just dripping by. What I'm going to come over here and do, this is just a terminal I have on my machine. And I'm going to go ahead and use the dig tool. So have you ever used Dig before, David?
Yeah. I'm surprised you're not using NSLookup, but there you go.
You can use that as lookup. You can use Dig. I've been using Dig lately more for just modifying commands and doing some more specific stuff that I want to do. So we'll get into that as we go forward. But what I'm going to do is just Dig. I'm just going to do David Bombal.
It's a dodgy website, that.
I know, right? And let's just get that, and let's just go ahead and hit it. So we can see some of the things that came back. I'm just going to stop this capture. And if I come over here, so I can see some of the flags that were set, the answer, I can see some of these sections, the question section, answer section, the answer that came back, and so on, how long it took. So a lot of this just gets pulled right out of the packets. So what I'm going to do over here on my Wireshark is I'm just going to set that filter for DNS, and let's actually dig into the packets on this side. All right, so you know the deal. Link in the description down below. You can download this packet capture, and you can follow right along with me and David as we will walk through it. So here's just a few examples of some DNS traffic. So first of all, I'm coming here, and it's just my lab machine. So 493, and I'm going to this destination of 4.1. There I am at the IP layer. And if I come over here, Wireshark summarizes that for me, davidbombal.com. Okay, so let's go ahead and unpack this a bit. So I'm going to just fly over the Ethernet 2s. There's my MAC addressing, IP, expand this, just take a look at my v4 addresses and so on. Wonderful. Even the UDP header, if I take a look here, so source port, desk port, so my client picks a client-side ephemeral port number to use. It's just a high number value. The one that I'm really interested in is that UDP port 53, length checksum, very simple. You know, the UDP is only 8 bytes. So intentionally, very simple, right? And that's why DNS initially used it. Just let's grab UDP. Let's not put a big load on that server. We don't need to establish a connection with the handshake, with TCP and all that's involved with that. DNS was not designed initially to be stateful. So we didn't have to, the two machines didn't have to track all of that, but really just send the simplest way and also give me that answer back over UDP. Okay, there's UDP. So let's expand DNS. So first we have this transaction ID.
Chris, sorry, dumb question. Just before you get into the DNS portion, source IP is your host, right? 192.168.493.
Yes.
What's the destination? Is that your local router or something that's acting as a DNS server or something? Is that right?
That is correct. So if I come down here, that's a great question, David. So first of all, how do I know who to send this to? And that involves my DHCP settings. So when I first wake up on a network, I ask for dynamic host configuration protocol. I'm asking for an address. And part of the information that will come back on that is who's my DNS server. So often we set that as an option with DHCP. So that way I know, hey, if I'm asking DNS, go here. And in this case, it is my router for my lab. Now, as we'll go on to learn, that itself, that router is not serving DNS. I don't want to look at it the same as a DNS server. Rather, it's a forwarder, and it goes and sends it to its DNS server that's in my ISP.
But anyone who's used to having a home network, let's say the internet service provider, AT&T, to use a US example, they get a little router at home that allocates IP addresses to the PCs, and normally the PCs point to that as the DNS server, even though it's not actually the DNS server, like you said. But from the client's point of view, that's the DNS server, correct?
That is correct. Yep. The client knows only that address, and whatever happens behind it, not my problem. I just want to know the answer. Yeah, it's magic.
Yeah. Brilliant. Sorry.
Oh, no, you're great. That was a good question. And please continue to stop me as I go forward. So transaction ID. So this is one of the first fields in DNS. Now it's just a 2-byte field, as you can see over there. And this just gives this DNS transaction a number to identify the request and the response with. UDP being stateless. Now the actual application, the server itself, can track this query goes with this response, or this response goes with this query. So I can have a lot of different DNS requests go to a server, and each transaction will have a different transaction ID. Now, Wireshark does something kind of cool. You see up here, David, on the top left, you have packet 1 and packet 2 with these little arrows that connect each other. Now, Wireshark is telling me, it's doing me a bit of a solid here. It's saying, okay, packet 1 goes to packet 2. Here's the query. Here's the response. And one of the ways that it does that is it matches up transaction IDs. So I can see down here in the response, you see that EFE6, EFE6. Well, there you go. Same thing with the one down beneath that. So 2BE9, 2BE9. So that's one way that it's able to track that transaction. Now, next, let's just breeze through the flags for DNS. I'm back on the query, and there's a few things that will fly over here. So first of all, that very first bit after the transaction ID, you see this right here, the 0. If this is a 0, the flag is 0. This means that the message is a query. If this is a 1, let's take a look at this next one. Then the message is a response. So just to show you a quick little cheat, if I'm ever interested in just the DNS queries that I'm looking at in a packet capture, well, then all I got to do is take that little 0. I literally am dragging and dropping right now, and I pop that up to my display filter, and now I can see all of my DNS requests. Now I can flip that around.
Just to let everyone understand, the query or request is from the from your PC saying, give me the IP address for this server, right?
That is correct. Yes.
Yeah.
I want this, I want to resolve this name to an IP address, or there could be some additional types of information that I want to know about that domain, not just IP address. There's some other ones such as, hey, what else is davidbombal.com known as? Or if I want an A record, which we see up here, that's just going to be a regular IPv4 address. But what if I want an IPv6 address? Those are the different types of records, which we'll get into in just a few minutes here. All right. So this is a standard query, nothing special. Message is not truncated. Park that for now. But basically, is this message all there is in this request or in this response? Or is there more? Do I bust the rules of DNS, or am I able to keep this response compact and in just one message? Recursion desired. So recursion is the fundamental way that you mentioned the magic of DNS. On the back end, behind my local recursive server or even my forwarder, behind that, hey, go and do what you've got to do to look up davidbombal.com. Do all the back end stuff because I want to know. Okay. So I'm asking, go ahead, do your recursion. And then there's some error flags down here that can help me. So just to keep that simple, next, questions. So within this lookup or in this query, how many questions am I asking? How many DNS requests do I have? And how many answer resource records are included in this query? Right now I have 0 because this is a request. It's not a response. How about authority resource records? So resource records that are authoritative or additional. So what additional stuff do I want to know either about this record or in the lookup? So it's no surprise here. You see here, I have one question and I've got one additional resource record. So that's the reason why you can see these fire up down here. I got one query and I got one additional record type. Okay. So in the query, I'm going to davidbombal.com and I'm saying type A, host address. So for right now, let's just keep this super simple. Type A means I want a host address. I want an IPv4 address for davidbombal.com. Now, there's a lot of different types. In fact, if you go to Google, chat, whatever you want to go look up, if you just look up DNS types or DNS record types, you're going to see a whole list of them. In fact, this is something that we cover on the Wireshark Certified Analyst exam. One of the questions that you're going to have to answer on the WCA exam, if that's something you want to go check out, you got to know the DNS record types. So type A, for example, regular IPv4. If it's a quad A record, 4 A's, I'm asking for an IPv6 address. It could be that I'm asking for a text record, and that can be notes or additional information that can be passed between a DNS server and a DNS client. So lots of different stuff. A CNAME. It could be that I'm looking for a name server. So there's lots of different types of DNS queries that I can ask for. In this specific case, I'm just looking for an A record. We good so far, David?
Yeah. So, I mean, I think the two that most people recognize is A for IPv4 and 4A's for IPv6.
Exactly.
And we won't get into the discussion of IPv4 versus IPv6 right now. We'll leave that for another day.
Exactly. Yeah. We'll leave that. We'll park that for later. So, David, before we move on to that response, let me just also peek down to additional records. There's some additional stuff in here. So basically the thing that we're looking for, this is more information for my server to know about me. Like right now, I can use extended DNS, which means I can have larger payloads. And you can see evidence of that right here. You see UDP payload size. So 4096. So if the network infrastructure allowed it, let's just say we're using a jumbo frame environment or something that went beyond an 1500 byte MTU, my DNS client is saying to the server, hey, you can send me up to a 4096 if the network allows in one UDP payload. I think about this almost like a TCP MSS in a way. It's like DNS is saying, hey, now when this first started, now this is important, everybody. When DNS was first written back in the day, this number was a lot smaller. It was 512. Now we're going to see why that's important when we look at how TCP also uses UDP, because newsflash, DNS isn't just UDP. It uses TCP as well. That's why something I've heard recently is people blocking TCP in their environments, thinking it's UDP only. And then they have DNS problems. Go figure, because it's not just TCP.
And for everyone who's watching, Chris and I did a bunch of videos on MSS, so I'll link those below as well. If you're interested.
Yeah, check that
and
out.
If you don't know what that is, don't worry. Have a look at those videos. Sorry,
Deep
Chris.
dive, TCP deep dive. Yes. Okay. Yeah. All right. So let's go into the next query, or this is the response. So here's our response. So message is a response. I'm just going to peek through. You see, it says truncated message is not truncated. What that means is I could fit all the payload in there, 68 bytes. I'm happy. I didn't need to extend this out. I didn't break I didn't go beyond the capabilities of the client. No error. That's good, right? No bad reply code. There was one question, which I echo. You see that question? I'm basically echo that back to you, David. Like, hey, here's the question you asked, davidbombal.com, type A. But there is an answer resource record. So, let's go peek in that and see what that answer says. So you were asking for davidbombal.com. You were asking for an A record, class internet. So That's the typical one you'll see with an A record. I'll park that for now. Time to live. So what time to live means is how long should this be stored in a cache before we should ask again for it? Right now I see 41 minutes, 54 seconds, and the address itself is 217.160.69. So what I would then see the client do is if I was going to davidbaumel.com is I would take that IP address and I would throw that in the next packet, which would be a TCP SYN or a conversation with davidbaumel.com. But that IP address would be the destination. So now I know where to go to and what addressing to use at the IP layer.
In this example, you're using a dodgy website. So there's only one IP address, right? But if I was going to Amazon.com or some big website, Netflix.com, would they not send back multiple IP addresses? Because I'm assuming they're doing all kinds of load balancing and stuff like that.
Yeah, you'll see a lot of different, not just one. In fact, here, like you mentioned load balancing, and that's one way that they do it. They give some group of users this IP to go to, and the next group of users this IP to go to. And that's a way that they can balance users across front end or even distribute them geographically.
So you might see like 3 or 4 IP addresses returned rather than one to your query. Is that right?
Absolutely. That's very common to see, especially with the larger systems like the ones you mentioned, Amazon, Facebook, so on. All right, David. So the next step, so we did a manual lookup. That was just for an A record and all that, but let's actually do the real thing. What do you think? Go out to your site. All right. So I'm going to capture this, get this going over here. Wonderful. Love it. Going to come over here. Let's do David Baumel.com. What a guy. Look at him. Okay. So we're going to see how this, I know, right? So let's go ahead and see what happened from a DNS perspective. All right. So I'm going to come over here and you can go ahead and download this PCAP in the description down below. Okay. So now we're going to go ahead and jump into the packets that we just captured going to your site. So we did a manual one with Dig. Now this is the actual site itself. So let's go ahead and take a look at this first request. And this is just looking for a type HTTPS. Let's actually see what happens here. So HTTPS specific service endpoints. So I'm out there asking, hey, do you have this type of record out there? Kind of curious. Let's go ahead and see, come down here. You see packet 1 and the response is down in packet 5. Just because I see request responses next to each other doesn't mean they go together, right? So remember that transaction ID is really important. So Wireshark goes, 3830. 3830 is down here. Let's look at the response type. So now I can see davidbaumel.com, service-specific endpoints. And this is where I learn a bit about the authoritative name servers with davidbaumel.com, a primary name server, a responsible authorities mailbox. So tell me some additional stuff about the davidbaumel.com name. But if you notice, though, this response came in after my initial TCP request to davidbaumel.com, which, by the way, side note for the packet people, you see I've got this name showing here on Wireshark. The way that you can do that, if I come over to Wireshark preferences, this is because I'm on a Mac. So if you go to Wireshark preferences, if you're on Windows or Linux, edit preferences. So if you go into preferences, this is where if we go to name resolution, and we can zoom in here. So this is where I've got MAC, transport, and network address resolution active. And I selected use captured DNS packet data for name resolution. So if a DNS request is within the packet capture you are analyzing, it'll use that name instead of the IP address in the address column. So those are the ones that you want to have checked. The other ones in that box that you saw, the reason why, David, I don't like to have those active is because this turns my machine into an active DNS resolver. It's trying to resolve all the IP addresses that it sees in the PCAP, and that can generate a lot of traffic if I'm not careful. So I like to have those unchecked, but I like to have this first one checked. So davidbaumel.com is resolved. So Wireshark pulled it out and put it in the destination field here. So we notice HTTPS came in. This is extra stuff about your site. But the second packet, if I look at packet 2, this is where the request went out. This was the davidbaumel.com request. I'm looking for an A record. If I come back 2 milliseconds later, I saw here's a type A. Here's an IP address. That's going to look familiar. Check out our time to live. You notice a few minutes ago, this time to live is reducing. Right? Kind of interesting. So that query may be updated by whoever upstream knows that resolution. And that's something I might have to refresh. All right. So I take that address. Now, next packet, packet 4. Now my machine is going out to that address that I found, that 217.160.069. And now I'm going out TCP. This is where if I come to my conversation filter TCP, this is where I start up that TCP conversation, fire up TLS. And then I'm having a conversation with your website, including that amazing graphic that came back, David Baumel with his arms crossed, telling us all about networking. So there's my DNS resolution. It's just a regular A record lookup and then a TCP conversation. And that's about it from the client perspective when I'm just doing a standard DNS lookup. Want to go deeper?
Of course, Chris, I want to go deeper. Come on. You got to give it. So that was like a nice intro for people who are new to this. And for everyone watching, please put your comments. Did you enjoy this? I love the way Chris explains this stuff. So I really enjoy it. But yeah, Chris, you've got to give us more.
All right. So the next question becomes, how does all that magic happen? What happens behind the resolver? And that's something that on my side, we can hopefully link that video as well. I just am releasing this series, but I go into that whole backend resolution. But here's the basic idea. So when you go to davidbombal.com, remember that when it comes to DNS, there's not a single server anywhere in the world that knows all domains. That doesn't exist. So what DNS has to do is it has to do a progressive lookup to be able to find the ultimate truth. Who really knows that IP address that just came back to me? So DNS is a hierarchical service. It is several different servers that come together to give you the full answer. Now, your resolver is responsible for doing all of that. And I have a slide that can help with this, David. So is it all right if I bring that up?
Of course, yeah. Sorry, Chris, just before we continue, you are putting this content in a lot more detail on your YouTube channel, which I'll link below. So you're going to go through this, like the PowerPoint presentation and other stuff in more detail. Is that right?
Yeah, I'm going to continue to build out this content. So in addition to what I put out on my own channel, also that's something that we can look at doing even on Udemy. So just to keep this very simple, David, I don't want to overcomplicate it. There's three major pieces that a DNS server or resolver has to communicate with in order to resolve a name. So if we just take a look at the client to the initial resolver, so that first caching name server or recursive name server, that's that first one that the client speaks to. That's what we've seen so far.
Like your home router. Yeah.
Yeah, exactly. Or even, let's go further. So my home router might even forward my DNS queries to that box that's in my ISP.
Okay.
It really just depends on what level of recursive DNS I'm doing. Is that my server, or is it just forwarding to the real recursive name server? So a request goes to that server. If the first thing that server does is it looks in its own cache and it sees, hey, in the last 34 minutes, am I still within the time to live of that davidbombal.com record, or has that timed out? If it has it in cache and it's still current, then it will just return the response right then and there. And that's when you'll get, from a client perspective, that's when you'll get a real quick round trip time. We actually just saw that in the packet capture. It only took, 2 milliseconds to hear davidbombal.com. So very likely that was cached. Now, let's just say it's not cached. What if I reboot or just clear the cache on my recursive name server? Let's just say we're starting completely over. Well, the first thing that the recursive name server has to do is it looks at that domain name basically from right to left. It goes, first, I have this com domain that I've got to go talk to. Now, I don't know who to talk to with com. So there's actually an invisible little dot to the right of com that we usually just don't talk about or use because we're usually blind to it. But in DNS, it matters. That dot means root. Go talk to a root name server and ask that root name server who knows about the com domain. Now, how do I know who to talk to with a root name server? Well, the recursive name server has a list of 13 root name servers that it is aware of, and it will go and it will communicate with those root name servers. Now, those aren't 13 individual boxes that it only knows about on the internet. There's hundreds of root name servers to support all of DNS, but there's only 13 root names. And I'm going to demonstrate those for you as we go forward, not just in this video, but for my full course. And as far as why there's 13, I'll tease that for later as well. There's a very specific reason why there's only 13 of them and why those names haven't changed. But think of these as the granddaddy. This is the starting point that I begin to fully do this lookup. Now, that root name server does not know davidbombal.com. It only knows who is the top level domain or who's the front man for the com domain. Okay. So think of a root name server. I walk into a library, David, and I want to find a book about TCP. So I walk in, and usually when you go into a library, who's the first person that you talk to?
Like the receptionist or someone.
Yeah, exactly. Now, does that receptionist know where the TCP advanced over Wireshark, the Wireshark certified analyst book is?
I doubt that very strongly. Ever heard of Wireshark? Never.
Right, exactly. But hey, that sounds techie. So what that receptionist does know is, hey, science fiction's over there. You got tech over there. Certification books are over there. So they know the major sections of the library, but they won't know exactly the shelf, the row, the area to go to. So think of that as the root name server. The root name server only knows about the top level domains. So I send davidbombal.com over there, and it hits me back and says, you know what? I'm not the master for the com domain, but I know who it is. Here's your top level domain server. Now, on the back end, the root name servers are constantly updating themselves with the latest top level domain servers and who they should go to. And that's beyond our field of view, especially from a query perspective, right? So hey, recursive name server, go talk to the top level domain. So now that's the front end librarian, and they're just saying, hey, go over to tech. So I go over to the tech section of the library and I say, hey, tech section, I want to study for my Wireshark certified analyst. So I'm looking for the WCA guide. So that person goes, that sounds like, let's just hone in a little further. I don't know every single domain that uses COM. Now, let me back up a moment, David. This is where COM could be COM, EDU, net, any of those, whatever follows the dot at the end of your domain name, you need a top level domain for that. Now, anymore, it used to be that these were real restricted to certain major branches or examples. So .edu, com, or country codes and things like that. But now you can use anything for that top level domain. I could have a .chris, Wireshark.chris. Ooh. Anyway,
There you go, like that. Yeah.
Man, I better register that as soon as we're done.
You better.
I will. All right. So top level domain. So the recursive name server says, hey, great. I was told to talk to you. I was given your IP address. So now I'm going to go talk to you and go ahead and hit me back with, the authoritative name server that absolutely knows the final current address for example.com or bombo.com. For the librarian example, this is like, okay, hey tech, who knows the actual shelf book location specifically within the library? And they're going to go, you know what? We have a specialist that's in front of this aisle, and that person will take you exactly to that book. And that's called an authoritative name server. Now, these authoritative name servers, these are the ones that actually have the true address, the true record that you've been looking for. Now, these ones are refreshed a lot. If ever there's a change in davidbombo.com where it's going to a different IP address, the authoritative name servers, that's the one that knows about the David Bombal part of the overall domain name. Okay, so it hits me back with an IP address. Now the recursive name server has an A record that it can then forward to the client. The client can then go and take a look at that address. It can go send a TCP send to davidbombal.com. Now the www, what that does is it just allows that server to know where, like you've already hit me as a server, but now where do you want to go within that server? Do you want to go to the web service? Do you want to go to the FTP service? Do you want to go to, what do you want to access on that server? All right. So that's the mechanics of the backend. Now, David, I'm just going to tell you right now that this is a very tough thing to completely capture, but that's where I got to thank our friends at Infoblox. They actually gave me a full recursive lookup. And
that's brilliant. Yeah, good.
Yeah, from start to finish, and it showed every step along the way, and it allows you to take a look at this whole thing. And for that, we can link to that video down in the description down below. If you want to take a look at it from a packet perspective, I have that on my channel.
I would have to get you back for that as well, Chris. I'm not going to let you get away with that.
Oh, 100%. We could do that. I mean, I was just thinking, since that's a bit since that's a bit beyond where we wanted to go today, we'll go ahead and plug that one for later.
Chris, I really want to thank you for sharing, and big shout out to Infoblox for sponsoring this video and giving you that peek up. Definitely want to get you back to talk about that. But have you got anything else to share in today's video?
I think right now, David, let's go ahead and button the topic and just keep it at that intro level. But coming up, I'm going to show you when and how DNS uses TCP. Super mindful. I was excited when I saw this, and I've got a couple great PCAPs to show you. And then that full recursive lookup. I'm going to take you through that whole back end, talk to you how that works, and actually how you even see TCP on that back end as well, which is why it's so important to just not arbitrarily block. And then after that, you asked earlier about DNS security. So getting into that piece as well. What are some modern trends with securing DNS, and not just the content, but the protocol as well. So we have a lot coming up.
But Chris, one last thing, right? You were involved in the creation of a very good certification related to Wireshark. So perhaps you can just give us an update of, firstly, what is the cert? What does it cover? And, what's happened in the last, about 6 months or more since you launched that cert?
Yeah, so it's been about 6 months since the launch of this over here, the Wireshark Certified Analyst. So it's been a very fun project that I had the pleasure of working on along with the Wireshark Foundation. So it's been going very well. I have a training course out there, the Wireshark Certified Analyst. We can link that as well, David, down below. It's a full lab generated, lab forward course. It is on demand that you can study for your Wireshark Certified Analyst. It's been well received by the industry. There's a lot of people that have started to take it and recognize it that, hey, this is a tough cert. It's not just about Wireshark itself, but it goes over several protocols, including DNS. It doesn't ask DNS to the level that we are going to go in this series, but it definitely asks the pertinent questions that every packet analyst should know about DNS. So even a series like this will help you to prep for the Wireshark certification. Is that something that you want to, if that's something that you want to sit for?
So Chris, on that note, actually, can I get you back to come and cover some of the topics in the WCA? Perhaps, people watching, give us your feedback about the stuff that you want to see. Perhaps there's certain topics that you struggle with. But Chris, I'd really like to twist your arm, get you back to, give us some free training on WCA topics and just guide us and tell us what's important to know.
Sure, I'd be happy to. And comment down below if that's something you want to see.
So for everyone who's watching, Chris has put a lot of videos on his channel. I've linked it below. I highly recommend that you go and subscribe to Chris's channel. If you're at all interested in Wireshark or DNS or even cybersecurity stuff related to Wireshark, Chris is the man I always talk to when I want to know anything about Wireshark. Chris, as always, thanks so much for sharing and thanks so much for making so much free content available so that all of us can learn from you.
It's great to be back, David. Thanks for having me. And I look forward to seeing all the Packet people again.